In this video, we're going to examine the complex conjugates theorem. In order to understand this theorem, we have to remember the fundamental theorem of algebra that states that the number of the degree of the polynomial is equal to the number of zeros. And remember, those zeros can either be real or imaginary. And the reason why we have to focus on this complex conjugates theorem by understanding the fundamental theorem of algebra is the imaginary zeros. Suppose A and B are real numbers where B is not equal to 0. If A plus BI is a 0, so if this complex number, A plus BI, is a 0 of the polynomial function, then A minus BI has to be a 0 of the function as well. And remember, A plus BI and A minus BI, we've learned in previous lessons when we discovered imaginary numbers are conjugates of each other. So if you have an imaginary 0, its conjugate is another 0. And that tells us that imaginary zeros come in pairs. You have the 0, the imaginary 0, and its conjugate. So let's take a look. We're going to kind of review our understanding of conjugates because it's been a while. So if we have 3 minus 2i, we want to find the conjugate of that expression. If 3 minus 2i is a 0 of a polynomial, then that tells me 3 plus 2i is also a 0 of the polynomial. The conjugate of 2 plus I is 2 minus I. The conjugate of negative 2i is positive 2i. The conjugate of 3i is negative 3i. Conjugate of 7i is negative 7i. And the conjugate of 4 minus 4i is 4 plus 4i. We learned before, and we can see up here, that our conjugates are the same terms, A, bi, they're just opposite operations. And so that's why if you take a look, whenever I had 3 minus 2i, I'm just going to change the operation. Here I just changed the operation, and F, I just changed the operation. Now C, D, and E are a little different because it's only one term, but it's still the same idea. This was a negative, so I changed it to a positive. Positive, changed to a negative, positive, changed to a negative. So to find the conjugate, you look at whether it's a binomial or a monomial, and you keep the terms and change the operation. And that helps us with this conjugate, complex conjugate theorem, that if we're given an imaginary 0, its conjugate is another 0 to the polynomial function. So you can move on to the next video series, which examines some problems dealing with writing polynomials given imaginary zeros.